Hey everyone! Today we're breaking down the physics behind one of the most important muscle groups in rowing, your quads.
Yeah. Rowing isn't just about pulling with your arms, it's actually your legs, specifically your quadriceps that generate most of the power.
That's right. When I push off, my quads drive the movement, and that's where the real force comes from.
So let's dive into the physics and see how the quads work to propel a boat forward.
Okay, so the quadriceps are made up of four different muscles. One is called the rectus femoris, which is right below the vastus intermedius, which is this one right on top. And then this one is the vastus lateralis. And this is the vastus medialis. Okay, so the function of these muscles are that the rectus femoris is the only muscle in the group that crosses both the hip and the knee joints. And it originates from part of the pelvis and inserts into the patella, which is the kneecap down here. And it assists in both knee extension and hip flexion in the quadriceps. The vastus lateralis, which is this one right here, is on the outer side of the thigh, and it is the largest part of the quadriceps, and it originates from the femur, and it inserts also into the kneecap. Okay, and then on the inner side of the quads, or the thigh, is the vastus medialis, and it is also attached to the femur and into the patella, and it also stabilizes the kneecap. And then vastus medialis, which is the one on top, is found beneath, or it's the one beneath, and it lies deep in the center of the thigh, and it's also from the femur and the patella. So as you can see, all these muscles that make up the quadriceps are from the femur, which is up here, and the pelvis, and the patella, which are the parts of it which is connected to bone. The quad's function is to help it straighten the knee joint and extend the leg. It also helps with hip flexion and knee stabilization. And it also helps to absorb shock while jumping and running. And this especially helps when rowing to help take the load of the human body and rowing.
Exactly, this is where Newton's third law comes into play. When Taylor pushes against the foot stretcher, the stretcher pushes back with an equal and opposite force, propelling them and the boat forward. When you row, you go through a motion called rowing stroke, which has four phases: the catch, the drive, the finish, and the recovery. The quads are the most active during the drive phase.
So the quads apply force to extend the knees, and that energy transfers into the rowing motion.
Yes, the force your quads generate creates torque around your knee joint, which straightens your legs That motion then converts chemical energy from your muscles into mechanical work, moving you and the boat.
This is the catch. Here my knees are bent and my quads are loaded like a spring, ready to push off. Here you go, just
Okay, so now I'm going to explain why the quads are a third-class lever system. So, I'm going to draw a person who is rowing. I'm going to have them be on like an erg. And they're pulling on it. Okay. So, the fulcrum would be the knee joint, which would be right around here. And then the effort would be the quads, because that's where the force applied is coming from, and that's just gonna be like up here, and it's gonna be pulling on the tibia through the tendon, and the tibia is over here, and the load is the weight of the whole body. Okay, just so that you can get a better look, this is the quads, this is the joint, and this is the tibia. So this is the pivot point, this is where the force is being applied, and this is where the whole load is going to be, which is just generally the whole body. In rowing, the quadriceps functions within a third-class lever system because the effort is applied between the fulcrum and the load. The fulcrum is the knee joint, and the effort from the quadriceps is pulling on the tibia, and the load is the rower's body weight. The setup allows for greater speed and range of motion, which is crucial in rowing. However, third-class levers are less mechanically efficient, meaning the quadriceps must generate more force than the resistance they overcome. The quadriceps are key in the power phase of rowing, working in a third-class lever system that prioritizes speed and movement over mechanical advantage. This design enables rapid and efficient knee extension, which is essential for an effective stroke.
Let's talk about power. Power is the rate at which work is done, and in rowing, it depends on force and velocity. The quads provide the force, and the speed of leg extension determines velocity.
So if Taylor pushes harder and faster, they generate more power.
Exactly. The equation for power is P equals F dot V. The force comes from the quads pushing against the stretcher, and the velocity is how quickly the legs extend.
And I guess that also explains why technique is so important. If you rush the stroke, you might not apply force efficiently.
That's why elite rowers train their quads for both strength and speed, so they can maximize power output.
Right. Rowers need to find the balance between force and speed for the optimal efficiency. Let's look at momentum. Momentum is mass times velocity, P equals mv. When the quads push off, they increase the rower's velocity, which transfers momentum to the boat.
So the stronger the push, the greater the momentum?
Yes, but there's a catch. Conservation of momentum, because the rower moves backwards, the boat moves forward. The goal is to maximize efficiency so that more of the rower's force goes into propelling the boat instead of wasted movement.
That's why rowers keep their strokes smooth. If you slam your legs too fast, you can disrupt the boat's movement instead of gliding efficiently.
So what have we learned? The quads are the powerhouse of rowing, applying force during the drive phase.
This force creates torque, generates power, and transfers momentum to the boat, all governed by Newton's laws and energy principles.
And that's why rowers train their legs so much. It's not just about arm strength. Quads are key to a powerful, efficient stroke.
Well, that wraps up today's breakdown of the physics behind the quads in rowing. If you found this helpful, be sure to like and share. Thanks for watching.